She acts like sometimes she has a lot. Okay, well, we're seeing Rhode Island. So, okay, so there, came back they did the most and then like gold actually had and you'll start but I have no idea
Are you doing?
Are you serious? I talks? What?
Okay, you done? So what did you say? Shh. All right, listen up. So he said, if the mass falls, oh, you say it. Go.
So if the mass falls nearer to the rim, the mass is more spread out rather than being compact. If the mass if the mass falls nearer to the center.
So
Basically, if the mass falls here, then later, because the mass is like more compact, the velocity is faster than the mass being more to the rim, so it's more spread out, so the velocity falls. So, yeah.
why?
Because like there's an equation and then later like
What equation?
it has something to do with inertia, the mass, the radius, and then then later the proportionality has to be kept. So basically, the
What
mass.
proportionality?
Um, okay, so
Hey, pay attention. I might ask you this question next.
okay, so the mass for both of them it has to be the same because you know we have
What mass?
the mass of the table and then the mass of the object that's being fallen.
Oh, okay.
Okay, so that has to be the same for both of them.
Okay.
And then later, the angular velocity is the only thing that's going to be different because obviously if it fall like that situation, like, so the angular velocity has to be like the only thing that's different. So I think that I has to be the same for both of them as well.
I has to be the same. You know, I from the table is the same. So what is I from the ball the same? Figure it out.
Yeah, the ball has to be different because
What's I for the ball?
I for the ball is m(r) squared and then later the root. The radius because it like falls.
Ricky, can you hit the on the air conditioner thing? Hit the on button for 3 seconds.
Because like the ball like it falls because the ball falls like either to the center or near the rim, like the radius is different. So the I for the ball is different for both situations.
So what happens to the I for the ball in the second situation?
The I for the ball in the second situation it like okay, so this R for the ball right there is like 2, and then this one would be like 3. And so because of that, then
Because of what? What does that do?
okay, so if you have 2 there and then if you have 3 there and let's say the mass is like 1, then that means that this one is like bigger than that one.
Okay, but why does that make it slow down?
Because it makes it slow down because
Actually, you haven't even said if it slows down. You just said so if it falls near the center, the mass is more spread out. That's all you said. Does it slow down or speed up? Okay, so you're saying it slows down.
yeah, so
Okay, why?
because okay, so it falls out to the center, and because of that,
Well, you already told me that I for the one on the edge is bigger than I for the one in the center. So why does that make it slow down?
can I make like a relation to this? It's like when you have okay, there has to be some
Figure out your explanation for this. I want to hear your explanation for this, each table. 30 more seconds.
okay, you know that the inertia is m(r) squared. So because the ball falling near the center, that mass is like okay, the mass is the same. The R, it's different because it's closer to the center. So the starting point is smaller. So then later, the bigger one has a bigger height, and because of that, it's like that directly ties into something, and um, maybe it ties into arrangement because like because the R is like bigger, then like okay wait. If you have like 2 over 3, and then if you have 2 over 4, that's like 66, and this is like 50. So okay, so then later let's say this is the omega of this thing, and then this one is the omega of two. Okay, so let's say that's the omega of this one. And so because like this is like the velocity and this one is the r. Yeah. Because this one is smaller. So let's say this is 3 and this is 4. And so because of this, if you divide this, you get 66. And then this one, if you divide this, you get 50. So omega is like smaller for this, and that's like how fast you're like rotating it. And so because it's like this one falls. This one is like slower, right?
Okay, well, that's fine. That's your final answer. Okay, so